when we have contact. This is annoying. There we go. All right. Okay, we'll go from current slide. All right, sorry about the lateness in getting started, but Cord, hey, here's Amanda. Had not. Okay. Before it gets and Tegan. Okay. So before we get started today, I almost hate to do it now because I know so many people will be coming in later. So I guess I will wait until it feels like closer to a full classroom. Here's Cody. Y'all remind me before the end of the class to go over our end game, what we're going to do wrapping up the term. Can't think of anything else. I believe today is the Christmas program, isn't it? The concert. I've seen the posters up. Is that right? Does anyone know? I remember seeing that. It's over on the Birmingham West Campus in the gymnasium sometime this evening. Trouble is, I've got mini-term physical science class that goes until 7:45. So I think here. So I don't think I'll be able to make the program, but the ones I've been to have been quite good. So if you can go to that, please consider it. All right, any questions on anything we've done so far? All right, we're in Chapter 3, which is exponential functions and their graphs. 3.1, I'm sorry, Chapter 3 is exponential and logarithmic functions. 3.1 is exponential functions and their graphs. Later we'll get to log functions. And here's Reggie. Okay. All right. We're on page 199, example 3, and example 3 does not have a slide dedicated to it. This was example 2. These are some of the values in an exponential function. And we talked about this before. These are actually two exponential functions. The first of these, 2 to the x, okay? And things to note here, all these exponential functions seem to cross that 0, 1, because when x is 0, anything raised to the 0th power is 1, except 0, and of course we don't have 0 as our base. But then when you get to higher bases, they rise more sharply after they pass through 1. But on the other side, the 2 to the x is more gradual and it's approaching 0. 4 to the x is very sharp in the approaching 0. So they're lower on the left-hand side, higher on the right-hand side as you go up in bases. Okay. And those are a few of the representative values. Huh? Z, right. I'm sorry? Sorry? And what about it? During class? You can't do it after class? Okay. Are you going to be in this room or in another room? Okay. All right. Let me get it for you then. Hey. Okay. Z came in. And R came in. I mean, Ron came in. Okay. All right. So that's how exponential functions look when you have how to express this. The variable exponent is going from left to right, you might say. In other words, the exponent is positive even though you can put negative values in. Okay? Example 3 is going to be the graph of another kind, and I think I'll graph it here, but not use that pen on my board. Use my ionizing pen and get my color set up. Okay. This time, we're going to be looking at two functions, capital F of x, and this capital F of x is going to be 2 to the minus x, and we'll also then look at g of x, capital G of x, which is 4 to the minus x. Okay, sorry about that. Let me get my, why will the pen not come up? There we go. 4 to the minus x. Okay? All right. He's here. He's here. Good deal. Okay. Gotta find you, though. There you are. Okay, Ryan's here. Okay. Now, we saw how they looked when, of course, you always have positive bases, but then when the exponents are increasing left to right, you saw how it went. These exponents, because of the negative sign, when you have a negative x, that makes the exponent positive, and when you have a positive x, it makes the exponent negative. So we expect, I hope you expect, to see just sort of the reverse action of what we had with these. So let's take a few and see. Pick me out some points, okay? I should have done different colors, shouldn't I? What color you want G to be? Anybody? Huh? Purple. All right. All right, so G is going to be the purple one. So let me go back to black, okay, and let's set up a table. We'll do x's, we'll do f of x's, and we'll do purple G of x's, okay? Oops, wrong. Okay. We'll also set up our coordinate plane here and go this way. All right, tick off a few points here. 1, 2, 3, 4, 5, 6, 7. Negative 1, 2, 3, 4, 5, 6. Positive 1, 2, 3, 4, 6, 7, 8. All right. So, feel like a cheerleader here. Give me an X. Say again? 0. All right. All right. Well, the 10 o'clock scholar again. Good deal. Okay, Kristen's here. There you are. Okay, and Dimitri is here. And Skylar is here. Okay, good deal. Anyone else sneak in while I wasn't looking? Okay. Now, let's do our f of x first. When x is equal to 0, what is 2 to the minus 0? Alpha of x equals 0. I mean, x equals 0. What's alpha of 0? There's your capital alpha of x over there. 2 to the minus 0. What is minus 0? Okay, yeah, the function is 1. Okay, let's go on and do our f's so that I can do it. So x is 0, alpha of x is 1. Okay, and here's Jake. So here you are. Okay, Jake's here. All right. Let's give me another x. 1. Okay. What's on f, when you put in a 1, 2 to the minus 1. 2 to the minus 1. 1/2. Okay, very good. Okay, so when x is 1, alpha of x is 1/2. Give me another x. Second? 2. Okay. And when x is 2, what is 2 to the negative 2? 1/4. Okay, when x is 2, alpha of x is 1/4. Give me another x. Negative 2. Okay. Negative 2. What would alpha of x be? I didn't write that down here, did I? Okay. 4. You're absolutely right. It's negative 2. We're up here at positive 4. Okay. Give me another x. Anybody? Second? Negative 1. Okay. And when x is negative 1, what is alpha of x? Alpha of negative 1? 2. Okay. Negative 1 would be 2. All right. Give me another x. Second? 3. Okay. When x is 3, what is alpha of x? 2 to the negative 3. 1/8. Perfect. 3 is 1/8. See the general trend on the right? Let's get one more on the left. What would that be? Let's do a negative 3. Okay, and what does that give you? Huh? And here's Alexis. Alexis, sorry about this. Okay. And I must have been psychotic because I already marked you here. Okay. Okay. I mean psychic. Okay. And what is alpha of negative 3? 2 to the minus of minus 3, which is 2 cubed. All right, here's Alexius. Pardon me? I can't hear you. Can you do it after class? Okay. All right. All right. Now, what was, when x is negative 3? 2 to the minus of minus 3, which is 2 cubed, is 8. Okay? Minus 3 will be up here at 8. That's 1, 2, 3, 4, 5, 6, 7, 8. Somewhere right about there. Okay, you get the general idea of what's happening here. Basically, the mirror image of what we had here. Okay? Whereas before, when it was 2 to the x, low on the left, large on the right. when you do a minus x, it just flips out across the y-axis. Where is it? There it is, okay. And now it's large on the left and increasingly small on the right, approaching 0. Okay? Let's do the same for 4. We've already got the x's. Let's figure the g of x. When x is equal to 0, what's g of x? 4 to the minus 0 is 1. Okay? So this will be 1 again. Okay? Next, when x is 1, 4 to the minus 1 is 1/4. Okay? So that will be down here right there. When x is 2, 1 what? 1/8. 1/4 to the minus 2 would be 1/4 squared. 16th, 1/16. Tiny little number down here. Okay? Okay? And when it's minus 2, oh, this is 1/16. When x is minus 2, (16) off scale. Okay, we only got up to 8 there, way off scale, somewhere up that way. Okay, so this will be 16. When x is minus 1, what is f of x? 4 to the minus 1, 4. We can plot that one. 1, 2, 3, 4, right there. Okay, somewhere right there. Okay, next, 3. And I didn't write this one then. Sorry about this. I'm just going to write it in purple. That one was 8. I forgot to write it in. 4 to the minus 3. 1/4 cubed is 64. I'm not even sure I can distinguish that from 0. 1/64. Okay? So that 4 there, ugly 4. And when it's minus 3, if minus 2 is off scale, this one's really off scale. So this is coming down incredibly rapidly here and then flattening out. Ooh, you don't go below 0, okay, but flattening out very, very fast. Exactly, yes.
I know that we did like a bunch of them, but typically once you just do like 3 points.
Say that again.
Typically once you do like only 3 points, for like a graph like this, typically once you only do like 3 points.
Okay, you can do as many as you want. I wanted to show what's happening on both sides of the x-axis. I mean y-axis. And I did 3 points here and 3 points there. If you just did 3 points here, you have no idea what's happening down here. If you just do 3 points down here, it doesn't tell you much. I think if you're doing, I think I know where you're coming from. If you're doing graphing a linear function, 3 points will do you, okay? Because any 2 points is going to give you a straight line. The third point is going to make sure that you're on the right straight line. If those 3 are not in a line, then you know you've got at least one of those points wrong. So then do a fourth one. But if they all line up, then you have a really good idea. That's all you need. Go from there. This is anything but a straight line. So I suggest you do a few more on both sides of the y-axis. Okay? So you see how it looks when you have a minus x there. It just flips everything across the y-axis from what we had before. There's what we had when you had 2 or 4 to the positive x. Here's what we have when you have 2 or 4 to the negative x. Make sense? All right. Reflections across, not, the function's not a reflection, but these two functions are reflections of each other across the y-axis. Okay. There is a checkpoint at the bottom of page, after number 3, and here's Ashley. Okay, good deal. All right, please do the checkpoints soon after you leave class if you can. That way it's fresh in your mind what we've done in class, and hopefully you'll be able to recall. And this irritates me. This has been doing this today without obvious reason why. I'm beginning to think, yeah, there it goes. Somebody who uses this classroom, other than me, takes the cord and ties it into a knot to store it up here, okay? I just sort of loop it around the box here, and I'm sure that falls off sometime. And I have a feeling that in doing all that manipulating of the cord, because this is this sort of a coax cable in there? Because I know it's DC, not AC, and it just seems like so aggravating. Now, it could be something in my computer, because this has hit the floor before, but there it goes. Okay. Hopefully I won't breathe wrong again. Okay. So, I breathed wrong. It just... Remember before when we had the cable problems, I had to drape it across the top. We changed cables and everything worked fine for a few months. Okay, computer, behave. All right, let's move on to the top of page 200, finally. All right. So here are some of the summaries of what we saw with our graphs. The following summarizes the basic characteristics of exponential functions. First we'll do y is equal to a to the x, and then y is equal to a to the minus x. Remember the restrictions on a, though. A has to be positive. Can't be 0, neither can it be 1. Okay. Strictly positive. No negatives, no zeros, not even a 1. Okay? Okay. With that in mind, then the x, the variable, can either be positive or negative. So if you have y is equal to a to the x, with a greater than 1 now, that makes a difference here. It can't be between 0 and 1, a greater than 1. The domain for exponential functions is always all real numbers. Okay? The range, remember our ranges? Both of those we did. Notice I drew the axis way down at the bottom. All right, please. Okay. There you go. Okay. All right. What was the range of all your exponential functions we've drawn so far? Range? Think of how the graphs look. Only positive, not even 0. Gets awfully close to 0, but never. So 0 to positive infinity. What was always the y-intercept? 0, 1. Always, okay? If it's just a to the x or a to the minus x or whatever. And they're strictly increasing functions, okay? Now, there is no vertical asymptote because the x goes on and on and on. Domain all real numbers, there's no restricted value for x at all, but there is for y. It approaches the x-axis is a horizontal asymptote. A to x approaches 0 as x approaches negative infinity. Now, the other thing, actually I like to say two things here. Smooth and continuous. Definitely a smooth function and absolutely a continuous function. Now, this is a leading question here. They're not talking about it yet. But since this function is smooth and continuous and strictly increasing, what does it guarantee this function has? Jakaya. Okay. All right. What does it guarantee this function has? Smooth and continuous, strictly increasing means it has an what kind of function? Always. Inverse. It has an inverse function. Remember, inverse function needs to be, what was the other name for it? One-to-one function, okay? And if it's strictly increasing or strictly decreasing, it has an inverse because those are one-to-one functions. They didn't mention it here, but that will come up later. Not too long from now either. Now we're going to look at a to the minus x, okay? Again, we're going to have a greater than 1, okay? What's the domain? All real numbers. The range? All positive numbers, not 0, but anything above 0. Does it have an x-intercept? Yay or nay? No, we said it never touches the x-axis. It never is 0. So it doesn't have an x-intercept, doesn't have a y-intercept. You can read it off the board, can't you? 0, 1. Always, every function of this nature, exponential function, that doesn't have any coefficients, doesn't have any added or subtracted, no shifts or anything, always passes through 0, 1. What's this one doing, though, as opposed to the... It's decreasing, strictly decreasing, okay? No vertical asymptotes because it has domain of all real numbers, but it does have a horizontal asymptote because this is approaching the positive x-axis as x gets larger and larger and larger. So, so it's approaching 0. So it does have a horizontal asymptote, and it's the x-axis again, but it's on the positive side this time. And it's smooth and continuous. And that means it will have an inverse function. Notice that the graph of the exponential function is always increasing or always decreasing. Never anything but. Okay? Which means always has an inverse throughout its domain. Always. Okay, as a result, the graphs pass the horizontal line test I was just saying, which means they are one-to-one functions. And you can use the one-to-one property, which we really haven't talked about, I don't think yet, to solve simple exponential equations, those that work out really nicely, okay? And here's what that is. For all a's greater than 0, but not equal to 1, if a to the x and a to the y are equal to each other, that means same base, x and y as exponents. If those are equal, that's only true if x is equal to y, because they're one-to-one functions. You can't have another value. So x must equal y. That's the one-to-one property. Okay? I don't think they're going to show any more than that. So, and they're not even going to do the examples of that. So let's back up a bit. Yuck. We'll go back to here. Clear my chicken scratch. And we'll do example 4. If I can get my pen rescued here. Okay. Here, ooh, let me get back to black here. All right. if you know that 9 is equal to 3 to the x plus 1. Okay? Now, we haven't solved any exponential equations yet. We're about to do our first one. We just saw one, but that was a very simple one. What do we do with that? A little bit of a hint. Let me go back to the property we're going to be using. That's right here. If a to the x and a to the y are equal to each other, then you know that those exponents are equal. Okay. Now here, we don't have that. We don't have the same basis. We have a 9 on one side and a 3 on the other side. But could we write the left-hand side as a power of 3 with the base of 3? Can you write 9 as some power of 3? Please say yes. Yes. Okay, what would it be? 3 squared. Okay. 3 squared is equal to 3 to the x plus 1. Agreed? Oh, and JT's here. Okay. Okay. All right. What does this, our one-to-one property, tell us then? If 3 to the 2 is equal to 3 to the x plus 1, what does that tell you? That what? Okay, absolutely. X is equal to 1. If you want to do a little more formal about it, that implies that 2 is equal to x plus 1, and then you could subtract 1 from both sides, and that gives you 1 is equal to x. Or just looking at it, if 2 is equal to x plus 1, x has to be 1, right? Because 1 plus 1 is 2. High-level math today. Okay. Does that make sense? All right. Let's do one that might be a little squirrelier. Not that any of these are squirrely. Okay. And this is the b part here. 1/2 to the x is equal to 8. Ooh, man. What must we do here? Can you write 8 as some power of 1/2? Or, if that's really difficult for you, you might be able to work with the left-hand side. Which way you want to go? Try to deal with the 8 only, or maybe massage the 1/2 to the x a little bit. Up to you. Pick one. Yes. Okay. Yes. If you flip this over and make that 2, then that would make it 2 to the minus x, won't it? Okay? Because here's the other way of looking at this. 1/2 to the x is equal to 1 to the x over 2 to the x. 1 to the x is 1, right? Okay? So this would be 1 over 2 to the x, which would be 2 to the minus x. Absolutely. Is that equal to? Now can we get 8 as some power of 2? Yay or nay? Huh? Yes. 8 is 2 to the third. Now we have the same base. Apparently different exponents, but they can't be different. This implies that what? Negative x is equal to 3, which also implies that x must be negative 3. Negative 3, okay? You can do that by either multiplying or dividing by minus 1, and that'll do it for you. Pretty ugly, isn't it? Pretty ugly. That's contradictory, isn't it? Okay. It's either pretty or it's ugly. Okay. So x equal, I left off my minus sign. Okay, minus 3. X is equal to minus 3. Make sense? These are a little stranger to think through, but you do have a checkpoint with two more of those, so do them. Okay? Now, I don't know why they left off example 5, because that's very different from the others we've done. So let's us do example 5, but it's not in the slide set, so I'm going to have to do it on this page again, or I choose to do it on this page again. In example 5, notice how the graph of y is equal to a to the x can be used to sketch the graphs of other functions, such as f of x is equal to b plus or minus a to the x plus c. In other words, we're going to be doing transformations. Just like we did with polynomial functions or other functions, we can do them with exponential functions as well. Okay? Now, haven't y'all seen this on just about every quiz and test lately? Describe the transformations of going from one function to another function. Okay, you get the idea. This author really focuses on that stuff. Okay, and you can see larsonprecalculus.com for a free website, interactive version of this type of an example. Okay, so describe the transformation from the graph f of x is equal to 3 to the x. We haven't done that one yet, but you easily could have. That yields each of these graphs. Okay? And I will draw the first one for you. Okay. First, let's draw f of x equal 3 to the x. Give me a few points here. Okay, give me a few points. F of x or y is equal to 3 to the x. Give me an x. 0. What's your y? 1. Okay, got that one down. Give me another x. 1. What's your y? 3. Excellent. 1, 2, 3. Somewhere up here. Okay. Give me another x. 2. What's your y? 4, 5, 6, 7, 8, 9. Somewhere right about there. Next one will be off scale. Guaranteed. So it's doing like this on the right-hand side really fast. How about on the left-hand side? Negative 1 will be 1/3. Negative 2 will be. Negative 2 will be. Help me. Help me. Negative 2 would be? Say again? Anybody? 1/9. Excellent. And negative 3, 1/27. That's close enough to 0 to me that I'm not going to mess with it. Okay, these are hugging the 0 axis. Okay, x axis. Okay. There's our base function, 3 to the x. Okay? Give me a color. Red. Is that what you said? Okay, red. Okay? Here is going to be, describe the transformation of the graph of this that yields each graph. So here's the one that yields. Oops. Something like that. Okay? This is going to mess it up, but I've got to do it. Okay? Let me try it again. Okay. What transformation has happened here? Shift up. Is that what you said? Absolutely. How much? 2. Okay? So up is in whose direction? X's or Y's? in the y direction, okay? So what you want to name this one? I think they name it G. So this will be G of x is equal to your f of x, 3 to the x plus 2. Not x plus 2. In fact, I would be real tempted to write it, just so you don't confuse those, 2 plus 3 to the x. That works just as well. And you don't get confused whether the plus 2 is with the exponent or not. It's not. Okay? But I was wrong. Okay? This is a different one. Sorry about this. I was just looking at it. In fact, I was trying to draw it that way, and it wasn't coming out too well. I should have guessed I was going the wrong direction. What we have done here in fact, I'm going to am I still red? Yeah, okay. This slid over 1. This should have slid over 1. Yeah. So I didn't quite have these lined up right. I should have been more careful because I got myself screwed up. Okay. What we have done here is not a vertical shift, but this is hard to see. Really hard to see. I've messed up the bottom ones too. Let me get that corrected as well. Okay. I should have done the points first, and then I would have not had this difficulty. Now I'll do them a little late here. Okay. Okay. Now it's a little more obvious. Okay? Hopefully, anyway. Notice here, this is shifted to the right 1. This is shifted to the right 1. This is shifted to the right 1. This should be shifted to the right 1. Low enough. I'm not sure the book did a good job of that either. That's what sort of threw me off. But you see, this is not a vertical shift. It looks like it is, but it's not quite. It's a horizontal shift. So what are we changing then? Not the y, but the x. So this g of x is equal to 3 to the x shift of 1. Okay, except x's always go backwards from what you think. So that's a plus 1. And that is up in the exponent. Okay, that's your shift on that. Sorry about that, folks. I sort of blew it by not paying close enough attention. Okay? Now, I'm going to take off the red graph, and especially since I botched it up so badly. Not sure I'll be able. Ooh, I lost the whole thing. Okay. I'll take this off too. All right. Go back to dark. And remind me. Huh? Okay, I'm sorry. I already marked you here. What's your name? Kiana. Okay, Kiana. Okay. Sorry about that. I know you're, oh, there you are. Okay. All right, good deal. Johnson, right? Okay. Okay. Now, let me get my axis back. Okay. I think we're back in business. Let me see if I can draw the B graph better. Okay, can we stay with red, or you want to go back to something else? Red, okay? All right. Yeah. This time, I'll plot my points first. There. there, 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 there. Okay. So here is our new graph. Now what has happened on this one? Yes, this is now a shift downward. Okay, now you see on both of these you had exponential functions, but because we had shifts, they no longer go through 0, 1. They go through different values. But this is a vertical shift downward, so what would be, and this one I believe is h of x. What would that be? 3 to the x minus what? 2, exactly. And I actually prefer to write that as 2, let's see, minus 2 plus 3 to the x. I really don't like that one either, but I think it's pretty clear that that 2 is not in the exponent. Be sure you draw it that way. Or you could write it that way, but I don't like leading off with a minus x either. Okay? So that was that one. Any questions on it? Okay, let's now do some more. Can I stay with red, or do you want me to go to a different color? Up to you. All right. Now, the next one, the C one here, has values here, and here, and here, and here, and here, and somewhere down there too. What is happening to this one? What would you call that? Reflection across the x-axis, and what would be your function then? I think this is k of x, negative 3 to the x. Did I lock? There we go. I just banged the computer. That'll do it, I think. Okay. So it may be more my computer. Now, you might say, wait a minute, I thought that the a could not be negative. Remember why I harped on that and harped on that? Well, this isn't negative 3 raised to the x. This is negative 3 to the x. The 3 is still positive. It's just the whole function is negative. That's why we can reflect it that way. Okay, you notice the difference? Remember the rules of order of operation. Exponents before additions and subtraction. So this is minus the function that we had here. Okay, not a negative 3 raised to the x. There's a difference there. Now, before we lose anyone, sorry, let me go and make these announcements. I said I'd make them earlier, but I wanted more people here. What's our end game going to be here? Okay, we're going to continue in chapter 3 today and Thursday. Thursday's the last day of class for this class. Okay, Friday and Saturday still are class. If you have Friday and Saturday classes, those are still class days. Okay, now. Then your final exam is scheduled for Tuesday at 8:30. I think it goes 8:30 to 9:20, I believe. Is that right? No, 10:20. 8:30 to 10:20. Okay? And your final exam will consist of 2 short tests. The first will be a Chapter 3 test, just what we've covered in Chapter 3 so far. The second one will be a comprehensive, and it'll be very short. You can finish each of them in less than an hour. But if you need more time, you've got all the rest of the week to work on either one of them you want to. Okay? Say again? Okay, not quite, but close. Let me explain the week. Okay. Are any of you graduating this term? Anybody? One. Okay. You have to finish before noon on Tuesday, because I have to get yours graded and the grades in, otherwise you're not graduating this term. Okay, so you have to finish by noon on Tuesday. So people whose exams are scheduled for Wednesday and are graduating, they've got to take them early. Okay, but you can squeeze yours in. All right, only one person graduating. Okay, now research papers. Research papers are due this week. If I don't have it by Thursday, then you start losing points after Thursday. Okay? And one more thing. If you haven't turned in all of your quizzes, which has only been 2, and completed both of your tests, then those papers are going back to everybody Thursday at the beginning of class. So that means if you haven't done them, you've got to finish those before class meets on Thursday morning. Okay? Now, if you are taking a test like one person is right now, okay, it's Walt, right? No, Jalen? Yeah. Okay, Jalen. Couldn't see under the hood. Okay. I know you're in here. There you are. Okay. All right. Sorry, let me start this over again. Okay. We have class today. We have class Thursday. Thursday's the last day of class. Thursday's the last day to turn in your research paper without losing points. Okay? And Thursday is also the day I return all the papers that I have from you this term. Which means if you have not turned in a quiz or not finished the test, you get the score you got at this point, which could be a 0 or a test that you did a little bit on and you got a 25 or a 15 or 83 or whatever. That's the grade you get. Okay? If you don't complete things before Thursday morning. Because Thursday morning at 8:30, I start returning those. So let me give you my office hours if you are going to try to make up some work. I'm free today between 11:15 and 3:15. Okay? That's about it, folks. Now, if you want to do something right after class, you can do that. You just will have to go. You can either stay in this room or go to another room. Okay? But I've got to have everything in before. Now, tomorrow my office hours are 2 to 4. Okay? And that's just about all I've got. A little window between 11:45 and 12:15. But that's a pretty small window there. So, you can see me during that window too. Okay? But 2 to 4 is a bigger chunk on Wednesday. Thursday morning, I'm usually here before 8 o'clock. Not long before, but before 8 o'clock, so you can get started on something between 8 and 8:30. But once 8:30 gets here and I've returned the papers, I cannot accept any late work after that. Okay? That's why I've been hanging on to them all this time. I'm sorry?
This Thursday or next Thursday?
This Thursday, yes. Okay. Now, I'm glad you sort of brought that up. Because next Tuesday, 1 week from today, is the final exam. Now, I want you to have all your work in front of you on Thursday so you can be studying over the weekend for the final. Okay? So that's why I've got to return them to you on Thursday. And I can't take any work after Thursday. Okay? I'll take research papers, but you'll be losing points after Thursday. All right. Any questions on that? Oh, yes. Yeah. Office hours tomorrow? That's Wednesday from 2 to 4 is the big chunk. Now, one other thing. Have you done the student course evaluations? No. Okay, please do those. Please do those. That's the best feedback that the school gets from you, and they really pay attention to it. And I don't know if y'all are aware of this. We're coming up on a SACS accreditation visit, and they look at those things, and they look at them carefully. Low percentage, then the school gets in trouble. Okay, so please do the student course evaluation. I value them. I'm a supervisor. I use those when I'm evaluating my instructors under me, so they're very important. And they ask you about other things occasionally. Has anyone done one this term?
Yes.
Okay. What, did you have any additional, besides the course? You didn't. Not, registration or library or food service or something. Usually they'll give you 1 or 2 other in addition to the course. But sometimes I guess you luck out and don't get the extra. But if you do you've done them all for all your classes? Just for freshman orientation. Okay. Yeah, they probably wouldn't do you one for that. So I meant for this course. Has anyone done the sheet of course evaluation for this course yet? Did they ask for any others? Say again? Okay, yeah. So you had some other. Usually it's only one or two for all your courses, but anyway. Okay. Got that done. Any questions on that? Yes.
Oh, no.
Okay. Any other questions?
Yes, you said 2 short tests, 1 chapter 3. You said comprehension test.
Say this one more time.
You said it's going to be 1 short test on
Oh.
chapter 3, and the second is a comprehension
Comprehensive. That covers chapters 1, 2, and 3.
test? Oh,
Okay. And that's the final exam. The others are chapter 3 tests. Okay. And they'll both be very short, and you can easily do them in less than an hour each. So you'll have plenty of time because it's 8:30 until 10:20. So you have an hour and 50 minutes. You'll easily be able to. But if you need more time, I'll be here afterwards. Okay. All right. Speaking of time, how are we doing? Oh, we got plenty. Okay. Now, I wanted to get that before we lost anybody. Okay. Now, that was C. Let's do D. Any questions on C? You notice there, it's not negative 3 to the x, it's negative 3 to the x, okay? The emphasis on the different syllable, okay? So let's take off that one. Oh, it didn't take it off. Okay. Let me try to get these. All right. All right. And let's do the last one, the D one. All right. D would be this one. Somehow I've lost that, okay? All right. Here is your D function. And this was called J of x. What would J of x be? A reflection across the y-axis, so what would that be? 3 to the negative x. Perfect. We did them just like that with 2s and 4s on the example 2 and 3. So yeah, this is 3 to the minus x. And that's what we mean by describe the transformation when you have these similar but different graphs. Okay, reflecting across the y-axis because you've negated the x, flipped it on the other side. All right, now we're ready for probably one of the most important new functions that you have not seen. Well, you may have seen it. This is the natural base E. Whoops, I said a function. This is a base, and it is a function, okay? We'll find out its duality in just a few minutes, okay? Natural base E. In many applications, the most convenient choice for a base is actually an irrational number. And this irrational number starts off 2.718281828. That looks like a rational number, doesn't it? Because it seems to have a pattern here. Does anyone have a calculator that will give you more digits than that? You don't. Okay. Let me see if I can do it on mine. I don't want to end this. Let me see if I can keep it. What's that? Okay, he has it. And you let me get rid of mine, okay? Let me go back to current slide. Okay. Give me a few more digits than what we have there. Let me get my pen back to black. 2.718281828. Does that continue? Really?
Oh, no. It's 45.
4 or 5?
Yeah, then 9, 0,
9045, and that doesn't continue either, folks. There is no pattern, okay? There is no pattern. It goes dot, 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 and keeps changing forever. Don't be confused by the 1828, 1828. That just is temporary. It never repeats itself, okay, for an extended pattern. All right, so this is called the natural base. Wait a minute, I've been told all my life we have a base 10 number system. And why do you reckon we have a base 10 number system? Because we have 10 fingers and 10 toes. And that's how people learn to count. So they just naturally gravitated that way. But once little old Isaac Newton got into the picture, he developed this thing called calculus. And once calculus was developed, lo and behold, the real base of our number system is that irrational number, e. What we mean by irrational number, it cannot be written as a ratio of two integers, ever, okay? Neither can it be written as a decimal that either terminates or repeats, and that's why I wanted to show you that doesn't repeat, okay? It keeps changing, okay? Now, that number is called the natural base. Then there's a function that comes out of it right here, f of x equal e to the x, is called the natural exponential function, okay? And here's its graph. And if you hadn't imagined this yet, imagine it now. Remember what it was when we did 2 to the x. It went through here and went up something like this. Then a little bit later we did 3 to the x. And it went here and went a little bit higher. Well, this is in between 2 to the x and 3 to the x. So it's just like all of our other exponential functions. The difference is it's an irrational base, which is fine. It's perfectly able to do. Now you'll see as we continue with it, it has some really neat features about it. Very, very neat features about it. Okay? So let's see what some of those are. Looks just like the shape of all of them. When x is equal to 0, e to the x is 1. Any base to the 0 power is 1. Except 0, of course, that can be a base. Okay? And when x is equal to 1, this is 2.71 equal to x, blah, 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 blah. Okay? Something between 2 and 3. 2 to the x would be 2. 3 to the x would be 3. So you see it's in between those two. And then 1 over e, or e to the minus 1, that's down here. It's a little bit greater than 1/3, because 1/3 would be less than that, 1/2 would be greater than that. Okay? E to the minus 2 is between 1/9 and 1/4. It's somewhere down there, closer to 1/9. Okay? So it just follows the same pattern as any exponential function. Okay? Be sure you see that the exponential function, f of x equals e to the x, e is a constant there, whereas x is the variable. Okay? E is a number. Irrational number, but a number. The variable is x. Okay? But that's still a very special exponential function. The natural exponential function. All right. So pull out your calculators and let's do some evaluation here. What is f of x? Well, let's do it this way. F of, when x is equal to minus 2, that would be f of minus 2. That would be e to the minus 2. Someone give me a value. You can either use your calculator or, well, you almost have to use a calculator. What does that give you? We just did it earlier. I said it's between 1/9 and 1/4. So I'd say point 3, something around there. Someone do it. What you got? Second?
That is e, right?
Yeah. E to the minus 2.
I didn't get it 3.
It's not 0.3. It's less than point. It's about 0.2 or 0.1 something.
0. Okay. I don't know. I might have did it wrong. I didn't get that.
Okay. Depends on, okay, what are you using? Phone? Okay. Okay, yeah, there's E, and do that to the minus 2 power. Yeah, 1.13. Yeah.
Oh,
Yeah, 0.13. So something between 1/9 and 1/4. 1/4 would be 0.25, 1/9 would be 0.1111, so 0.13. Good deal. Now, read that out, or give me a few of those digits again. 0.13, blah, blah, blah.
0.1353352.
Okay. And by the way, another irrational number, if you weren't surprised by that. All right, let's do f of -1, which would be e to the -1. Now this will be something between 1/2 and 1/3, so about 0.4 something? 0.367, okay. Is that right? 0.367? Okay, yeah, blah, 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 okay. Perfectly fine. It's closer to 3 than it is 2, so that makes sense. All right. How about when x is equal to 0.25? So f of 0.25 would be e to the 0.25. And what would that give you? This is something greater than 0. So it's, 0.25 is greater than 0 but less than 1, so this is something between 1 and 2.7. 1 point, say? 1.28, blah, 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 okay? And if we're x is equal to -0.3, that would be f of -0.3. That would be e to the -0.3, and this would be something, about 0.5 or 6? 0.74. 0.74, blah, 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 blah. Okay, good deal. All right, any questions on that? You see how to enter those on your phones or calculators or whatever. It's the exponential function. Did everyone able to get those? Because you will need to do these on your test, okay? So be sure you know how to use your calculators. Yes? Okay. There's the e to the x. Okay. And what you want to do? -2. So I think on yours you have to do a 2, change sign. Okay. On that you have to enter the argument first, then the function. That's why I want you to do them and make sure you can do it either on your phone, your calculator, whatever, because I don't want you missing them on the test because you don't know how to use your device. So learn to use your device. Okay? Any other questions on that? All right. Oh, here we go. They show you how to do it. E to the -2. Now this is on graphing calculators. If you don't have a graphing calculator, you have to know the syntax for yours. Skylar had a phone that used the old scientific notation. Okay? And on that one, you do things sort of backwards. You do the 2 change sign, which on her calculator was a plus or minus sign, and then that gave her -2, then she hit the E button, E to the X button. For those who, like Ryan, he had the E key and then the negation key, 2, and that gave him that. So you have to know your calculator, your device that you're using and what syntax to use. So make sure you have that figured out. Okay? The old scientific calculators, you did the argument first, then did the function. On the newer graphing calculators and some of the phones, you do this order. Okay. So basically, if your negation key is that minus in parentheses, then you do it in the order. If it's a plus or minus key, you enter the number 2, then change sign. And the oldest calculators, it was a CHS key meant change sign. So you had to enter the number before you change sign. All right, on this one, same type deal. On the scientific type calculator, you do 1 plus minus e to the x. On the graphing calculator, it's e to the x. The negation key, which is a minus in parentheses. Don't ever use the straight subtraction key. That will give you a wrong answer. If you're changing sign, if that's all you're doing, be sure it's a minus in the parentheses, 1. And that gave you 0.367, blah, blah, blah. These should have dots after each of those. Okay? The 0.25, this is going to be something greater than 1, less than 2.7. So this is right around 1.28. But this is, and if you have one like Schuyler's, a scientific calculator, 0.25, then press the e to the x key. If you have a graphing calculator or other phone application, it's e to the x key, and then enter the 0.25, or put the 0.25 and press enter. You get 1.28. If you know what the graph looks like, which you should, we've been doing those, you should have a general idea of what value your number should be, your answer should be. And on the last one is alpha negative 0.3. Schuyler would be 0.3 plus or minus, then e to the x. On others, it'd be e to the x, the negation key, 0.3, enter. Okay. Any questions on that? All right. We'll pick up next. Oh, whoa. We'll do example 7 is where we'll start next time. Okay. We did example 6, but they don't have example 7 on the slide, so we'll do that. That's where we'll start next time. All right. Remember, at the very beginning of class next time, I'll return all your work to you. So please come see me today, tomorrow, or 8 o'clock Thursday morning to turn in any old work. Past work that's already been due. If you haven't finished the test, please come and see me. Now, anything that's been turned in this week, I don't have on Blackboard. But if you have stuff that was done earlier, if you don't see a grade there, that means I didn't know if you were finished or not. So I left it blank just so if you wanted to come back and finish, you could. But you got to have it done before Thursday morning at 8:30, because there, whatever you got there goes. All right, good deal. We'll see you Thursday.
Okay, about the class.
Which day?
From Thursday.
Huh?
From Thursday.
From Thursday. Have you turned in the quiz?
Yes, sir.
Okay.
Yeah, quiz 2, right?
Huh?
Quiz 2,
Quiz
right?
2, right.
Yes, sir.
Okay. All right, and you ready for the test? You going to do it now, too? Okay. Let me, this here. You have something, or, research paper. Okay.
Did you get it yesterday?
I'm sorry?
Did you get my test?
Yes.
Okay.
It's graded. I just don't have it in Blackboard yet.
All right, because I took it to the door.
Yeah.
I wasn't sure.
Yeah. I
I
got
couldn't
it.
find you yesterday.
Okay. So, is everybody standing here waiting for test 2?
Yes.
Okay. Have any of you already started test 2?
Me.
You have?
Yes.
Okay. Are you going to work in this room?
Yes.
Okay.
I don't know what college is.
Okay. Okay, I hope you've all turned in quiz 2, otherwise it becomes a 0 if you don't. Okay, all right. All right. Are any of you already started on? You have, okay. Okay. Here you go. All right. Anyone else already started on the test? All right. The rest of you are here to pick it up and go. All right. You need graph paper?
Yes, sir.
Okay. Hold on to this. Graph paper. Did y'all have a question? Are you waiting on something? Okay. 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 You're starting from, yeah. Okay. You need graph paper? Okay. This is awkward. Sorry. Okay. Need graph paper? You haven't started, right? Okay. You've already turned it in, or?
What was I saying? Okay, I did test one.
I'm sorry?
I did test one. Quiz 2 and quiz 1. So what I mean, I just.
Okay. Yeah, I haven't entered any of the grades from last time. Did you finish test 2?
I need test 2.
You do? Okay.
And
Had
I'm
you?
bringing it back tomorrow because I got
No. This is an in-class test.
Okay, right.
Huh?
Well, can I just come? When can I do it?
You tell me.
Can I come tomorrow?
Tomorrow between, say, 12:15. No. 11:45 to 12:15, or between 2 and 4.
Between 2 and 4.
Okay. Come tomorrow. It could be either in the classroom 255 or my office 265.
Okay.
Test 1. Have you started it? Okay. Okay. Do you need graph paper?
Yeah.
Okay. Okay, you had turned in the quiz 1, right?
Nah, I got it. I'm bringing it to you tomorrow. I'm coming tomorrow because I'm taking test 2 tomorrow.
Well, you're supposed to do the quiz before the test, but I'll let you go and do it because you need to get it done. Have you got quiz 2?
Yeah.
You do? Okay.
Can I get it just in case?
What's that?
Can I get quiz 2? Just in case?
That's what I'm asking you. Have you got quiz 2?
Yeah, but I'm not sure if I still got it. I did it. I got the work to show for it, but I just got it.
I don't have many because of, if you've already given you one. Okay, do you need graph paper for that?
No, I still got the Wednesday.
Yeah. Okay, but those are 2 different things.
Yeah.
Okay. Okay, Ron, what did you need? Oh, wait, what do you need?
No, it's okay.
Oh, okay. I'm sorry, I can't read.
I have no research.
It has to be word processed. Yeah. Yeah. Okay. I can't hear you.
So for my research paper, is it okay if I put like all our terms? Is it okay if I put like, $60 like that? Like,
Sure.
oh, okay, cool.
Yeah.
And also, is it okay if it's double spaced?
Yeah, it's
And
supposed to
this
be
is
double
due at
spaced.
8:30 on Thursday.
Huh?
On Thursday, so at 8:30.
Yeah, yeah.
Okay, so the thing is, like, I go to UAB, so I'm always late because.
Okay.
Okay, so thank you.
All right.
But what are your office hours for tomorrow?
Okay, I mean, no. Okay, if it has to be turned in before class by the time, actually anytime Thursday.
Anytime Thursday?
Anytime
Okay,
Thursday.
thank you.
Okay. What was your, okay.
I need my test.
Which one? Test
Test
2? And you've already started it, right?
Yes.
Okay. There you are. Stuck on another one.
And here's my research paper. The library, they have complications, so we print it front and back.
That's right. Okay. All right. Anybody else? You okay? Okay, everybody? Okay. I recorded all that, by the way.